really excited to have you here tonight for this launch of a second version of maybe a launch from a pilot of a really exciting upcoming student opportunity that we have. I am so excited and thrilled that everyone's here today for our discussion. On behalf of the Data Science for Everyone Coalition, welcome to After the AP Test Data Science Challenge. My name is Eric Drosta. I'm the Executive Director of Data Science for Everyone. To give you a little bit of background on our group, DS4E, or Data Science for Everyone, is a national initiative, coalition, and community based at the University of Chicago. And we're striving to catalyze the adoption of data science and data literacy as a basic component of K-12 education. We originally were catalyzed from a Freakonomics podcast, of all things, but the push for data literacy has since become a national movement with more than 3,000 education leaders across the country, including many states and districts who have put their efforts into advancing this work for students. We currently work on four primary things. We help raise awareness. We gather and catalyze classroom resources. We try to do the best we can to build some community around this work and try to advance policy and technical assistance as it relates to data science education. Before we jump into the meat and the substance of today's conversation, I want to remind everyone about the Data Science for Everyone community standards. We welcome coalitions of all different backgrounds and levels of experience with data science education. To create room for healthy and engaging debate, we've established a code of conduct that creates an environment of respect, inclusion, or effective communication. You can learn more about our community standards, including how to report any violations that might occur on our website. And we'll also drop a link in the chat now, so you'll have access to that in case you need it. Also, before we dive into our panel discussion, I'd like to make a huge thank you to our partner, Skew the Script, who's helped us organize this work. Skew the Script offers free AP Statistics, Algebra 1, and Algebra 2 lessons that situate math in relevant context. Example questions could be like, is college worth the cost? Are electric cars actually greener? Can you make living as an influencer? Who's the best basketball player of all time? Their nonpartisan lessons challenge students to tackle these questions with statistics, mathematics, and hopefully some critical thinking. For the event today, you'll hear from the executive director of Skew the Script, Dash Young-Zaver, about the Data Science Challenge. And Dash just waved, so you can see him in the chat here with all the speakers. In addition, you'll hear from Mahmoud Harding, who's our instructional design director here at Data Science for Everyone, and Jennifer Huppert, who teaches in Wappingers Central School District and participated in the challenge last year to help bring this opportunity to our students. After they shared their experiences with the challenge, we'll leave time for open questions at the end. So ask everything and anything that you might want to hear about the process, what the challenge structure looks like, experiences in the first cohort that we ran last year. And please make sure to drop any questions you have into the chat, either now or throughout the event. We'll do our best to capture those, and then we'll try to catalog them for the end so we can make sure we can have a group-led discussion. So with that, some of those great details just to help orient us here. I'll go ahead and pass it over to the Dash to get us started and to tell us more about this awesome upcoming opportunity for students.
Wonderful. And thank you so much for having me. And thank you to Data Science for Everyone and our partners at, of course, CADA, NC State Data Science Academy, and for being supportive of this project and being able to bring it to so many students. It's just such a pleasure to be able to facilitate this with a bunch of AP educators who care so much about student learning and students having relevant tasks to do in the often dead time after the AP exam when we're struggling to find content and find things to do that are truly relevant for students. And I think for a long time now, us in the AP teaching community have found that while the skills we teach are incredibly important, they sometimes don't measure up to what's being done in the modern world today. And this is a chance to give students a window into that world without it being an overwhelming window. So without further ado, I'm going to share a little bit about the challenge via sharing my screen. So, where's the first one? If you go onto the Skew the Script website at skewthescript.org/data science challenge, you'll find a landing page where you can find out a bunch of info about the challenge and how to register. I think folks in the webinar will be dropping the link directly into the chat. but it talks about all the stuff you need to do the challenge and the context of the challenge. The main context is using big data from the Department of Education to predict which colleges pay off the most. And this is a question on a lot of students' mind, especially the sophomores, juniors, and seniors that we may be teaching in AP courses who are considering going to college and are thinking about how do I do so in a financially sustainable way. And we use big data to try and figure that out with students. So they're going to work through the open source R coding language using Jupyter notebooks, all hosted through Course Kata's great Jupyter notebook platform. DS Free helped with providing capacity to Course Kata to build out more server space to accommodate more people using the platform, and we're extremely grateful for that. As they work through the notebooks, they'll be able to explore text, images, and do code in this nice, clean format that almost is kind of like a handout. But instead of doing your raw coding and ones and zeros on a huge interface that normally would be very intimidating, this is a lot more approachable for students who may be new to coding. At the end, students can model out a predictive model, machine learning model of trying to predict on a test set, an unseen data set, the student loan default rates at different schools based on variables like the size of the school, the proportion of students at the school receiving Pell Grants, the graduation rates of the school, et cetera. Find the most predictive variables and try and make a predictive model to see which schools are going to have the highest loan default rates and which ones won't. And then they can submit that to an optional prediction competition and get recognized as a national champion for having the most predictive models. And so that's a really cool opportunity for students who want to go above and beyond. So what you need to use the Data Science Challenge is to have either completed with your students 1 full year in AP Stats or AP Comp Sci A or AP Comp Sci Principles. So if you completed one of those 3 classes with your students, you have the material you need to start the exam, or not the exam, excuse me, the project. And if you've done a lot of stats for your students, but no coding, that's fine. The stats stuff will help you along the way, and the coding will be taught through the notebooks as you go along. If you've done a lot of coding with your students, but not done a lot of statistics, we have the supplementary material in statistics to help you learn that as you go along. It would take approximately 1 to 2 weeks of class time after the AP exam, and you don't need to download anything to any machines. It only requires internet access and access to computers, laptops, or Chromebooks. There's no need to install anything. You just need to get onto the platform and start using it with an internet connection. The things that you do not need, which is, I think, as important as the things you do need, are prior exposure to coding, as long as you have that background in AP Stats. Prior exposure to statistics, you don't need that as long as you have that background in an AP Computer Science course. You don't need to download any special software or have any special computer power. We have that free of charge for you. And again, everything is free to access. So money is no barrier here. You can get started without any upfront funding. The steps to get registered, if you are an AP teacher, by April 19th, we ask that you fill out the teacher registration form. And then in the ensuing weeks, start to explore the materials in our Canvas course where we're hosting all this. To give you a quick sense of what that looks like, when you log into the Canvas course, you'll see there's material to go through and an instructional video on how to get started. And then we have the actual code notebooks that you get to use with students. There are 4 notebooks proceeding through different data science material. Mahmoud will be covering these more in depth, but to give you a quick sense of what these things look like, there's text and images in this nice intuitive structure, and line by line, it walks students through how to do the R coding required, how to download libraries, how to download the data set, how to print the head of the data set so you can see what the data is involved in the project, and then various skills as you go through, including data visualizations from histograms and box plots, which we'll see down here, to bar plots. And the material goes on into simple linear regression, multiple regression, and then some basic machine learning models with polynomial fits. Last year, we ran the project with students in a pilot. We had about 2,600 students participate, which was amazing. And they were from schools all over the country, across private, charter, public schools, and across multiple states. And I think, so this was a report compiled by NC State following the first data science challenge. And we didn't know exactly what the results would look like. This was the first time we did a project of this scale with so many teachers and students. And we were pleasantly surprised by the results. Most students completed all 4 notebooks, which was quite amazing. And if you look at the prior experience with these materials, most of the teachers that were using the materials with their students didn't have any prior experience with the R coding language or Jupyter notebooks, or only had minimal. But they felt that learning those things was not at all difficult, or close to not at all difficult. And then with students, the level of coding difficulty they rated was at 3 out of 5, roughly, for most of them, which means that it was of a difficulty that didn't feel trivial, but also not overwhelming, which is amazing. And a lot of the students were coming from AP Stats backgrounds and had no prior coding experience. They also generally tended to feel very engaged in the notebooks, especially when talking about the context of trying to model college debt and trying to predict the amount of college debt you might expect at different colleges and what the predictors of that are. And so overall, we found that students were highly engaged and prepared to do this kind of work after taking either an AP Stats course or an AP Computer Science course. At the end of the pilot last year, we got to announce the Data Science Challenge champions, which was very exciting. We had a bunch of students submit models of different predictive accuracies to see if they could predict on a hidden test set what different college student loan default rates would be. And we had here 10 teams as the champions who had the highest R-squared predicted values on that hidden test set. And this year, we hope to see even higher submissions on a new hidden test set for this year. And we're excited to see the submissions that come in and see what kinds of models that students come up with. In addition to the 10 students listed here, we also had many other submissions in the runners-up who also made incredibly good models. And this is a great thing for students who are applying to college, maybe in the next couple of years, or applying to internships. They can say, hey, I was a finalist or runner-up in the National Data Science Challenge. And that's always a very impressive thing for them to share. So that's a big overview of the challenge and what happened last year and how it generally works. And I'm going to pass it off to Mahmoud to go into what some of the materials really look like and the progression of the modules.
All right. Thank you, Dash. So let's see, share my screen here. And so I thought about how to do this. And one thought was to go into a notebook and actually show you what it looks like live. But then I thought I would be spoiling all the fun for you. So what I'm going to do is what we do in Hollywood, what they do in Hollywood. I'm going to give you a trailer to sort of whet your appetite for what you can expect. The question that I asked in the chat was how many people have experience with R? And notice no matter whether people put yes or no, I gave a thumbs up. And the reason I did that is because we put together videos to help you walk through the notebook so that you can be prepared to work with your students. And it gives you an opportunity to see what they're going to see and experience some of the difficulties they may experience so that you can empathize with them as they're working. Second thing I asked, did anyone ever use any Jupyter notebooks? And notice that whether you said yes or no, I put an explosion, a party, because this interface, in my opinion, is the best of both worlds. It allows you to do computing and format text and images all in one workspace, preventing where you don't have to download any additional software to run it. So without any further ado, like Dash said, we're going to be working through the Course Kata Jupyter Hub. You don't have to do any setup. You just log in through the Canvas, go into the Canvas course as it is, and you have access to everything that you need. Just as Dash said, we're going to be working with this college scorecard data. I suggest that you take 5 or 10 minutes to let the students take a look and browse around and let them see where this data is actually coming from. This is a U.S. Government website. They collect information on all U.S. universities and colleges. And so this sort of gives them sort of an anchor to let them know that this wasn't something that was made up. It's actually real and it's updated every year. So notebook 1 is just basic R and data exploration. So notice we say basic R. A lot of people, when they think data science in high school, they think data science the profession. We're not professional data scientists, and we're not trying to make you a professional data scientist. What we're trying to do is give you the tools that a data scientist uses in their profession, in your classroom, in a manner that is aligned to what level your students and you are at. So we're talking about at most 8 commands and a specific package that allows you to model with linear functions, polynomial functions, and also allows you to do all kinds of visualization. So in 15 or so commands, you're able to do things with data that maybe 5, 6 years ago weren't possible inside the classroom. And the example that I like to give is you have a TI calculator. It has all kinds of functions. How many of them do you actually use? And you feel very comfortable with that tool. So you can think of this R programming language as the same way. And we're going to show you how to use R for what we need to use it for. So the format is the questions about the data and the exploration drive the R that we learn. It's not the other way around. We're not learning R commands just for the sake of learning them. We're learning R commands because we want to answer questions that we have. So are you excited? You ready to go? I see some heads not yet. That's what I'm talking about right there. That's it. The next thing we're going to do is something that everyone does since the 8th grade, simple linear regression. We're going to do it in a manner that's real because we're going to look at simple linear regression in the context of something that many people will have to deal with, choosing a college. Why do you choose a college? Do you choose it because you like the sports team? Do you choose it because you like the location? Do you choose it because of the major? What makes for making good choices? A lot of times when we make choices, it's not a simple linear regression choice. We use things that are numerical, like how much money it costs, what SAT score do I need to get in? And we use things that are categorical. What are the school colors? What region of the country is it located in? Which colors match my skin tone the best? Where did my parents graduate? I don't want to go where my cousin went because I don't want them spying on me. So these are choices that we make that are not really built for simple linear regression. So we need multiple linear regression because we make decisions based on multiple features. When we decide we're going to do something, some choices have more weight than other choices. But we, in our minds, sort of think about how these things play together in order for us to make our choice. And we want students to see the power of multiple linear regression. But we don't do it in a way that is based in a set of numbers that has no meaning. We do it using data that has a context that they can understand. SAT scores, economic things like net tuition. Did I get a Pell Grant? Do I have a loan? These are things that they can reconcile in their mind, so it helps them understand how these different variables play together. But many times data we have doesn't really line up linearly, and we need machine learning. Well, why do we need machine learning? Because sometimes the way that data looks in a scatter plot doesn't fit a line. So we need other math functions in order to try to model what's happening between those points. We can use things that we normally use abstractly in context. For example, a second degree polynomial. a third degree polynomial, a 12-degree polynomial. Because our goal is to try to make sure that we can try to make good predictions based on the model we make and using the data that we have input into that model to give us values that are output from that model. But there's a trick and a catch. The trick and the catch is for you to find out when you go through this on your own. The idea is there's always a balance and a trade-off. And we as adults know that in life, there's trade-offs and balances. Notice that the icon here is a scale. And in this particular aspect of the project, students have to see what that trade-off is. And the trade-off that you're going to experience when you go through the notebooks the first time on your own, looking at videos that were done by me, so you get to see me again. I don't know how good that is, but you look at the videos that are done by me, and then you get a sense of what these trade-offs are and how you can reconcile them for yourself to help your students as they go through the project. And finally, I encourage all of you to jump right in. Don't be afraid. If you have any concerns about whether or not it'll be too difficult, just overcome those fears, step right in. Don't be afraid to learn with your students. And with that, I'm gonna pass it off to Jen.
Oh, Jen, you might be muted. Oh, yeah, just make sure you're, yeah, there you go.
Sorry. Hi, I'm Jen Huppert. I teach AP Computer Science A, so coding in Java, and AP Stats. And after my school goes into the end of June, and so I really have a lot of time after the AP exams for activities with the students. So I'm always looking for really meaningful activities. And typically we do a big project, but that still doesn't always take all the time. And so when I saw this come last year, I really jumped on it because I love that idea of having, first of all, that meaningful data and the large data set. Because in AP Stats, we really just play with small data sets all year. And so here, not only was this a really big data set, but it offered a lot of, it was meaningful to the students at the time. So I really enjoyed that component. And also coding in R, because in my class, I definitely don't have time to go into that, or I don't feel that I have time for that. So we stick to calculators, Statlet, maybe some Excel here and there. And so here was this opportunity to use R, which is widely used outside of my high school anyway. And so really when I saw it, I sort of saw it from the AP statistics side first, but then I knew for my comp sci kids, the idea for them to learn something that might typically be a little uncomfortable for them, to learn a little bit about the statistics, but to code in another language. I mean, those kids just eat that up. They were all about it. So that was actually really interesting to see in terms of that. So I had no experience with R or Jupyter before I started this, which was another reason probably that I didn't include R a whole lot in my course, because I didn't know it, right? I mean, I used, I think, SPSS many years ago in grad school. And so being able to learn this first, I thought, okay, I can definitely, take advantage of this. So I signed up early and then, went through the notebooks myself to make sure that, to see what it was all about and so that I could learn it and figuring out like, where do I think the different classes will struggle or have questions. And so I used it right after the AP exam. Our exam is early. And so I have that a lot of time to fill in, and that after our exams kind of chopped up because students are often taking many different AP exams, not just mine. And so what I liked about this is that it was very individual and self-paced. So I didn't assign anything as homework. Nothing was homework. and I gave them a taste of it beforehand. And so yes, by doing this, I kind of gave them soft deadlines. So, after I figured out who was going to be in class when, okay, so everyone should be done with this notebook by this time. And then everyone should be done with this notebook by this time. And doing that, it still took, I think it took about 2 weeks to get done, even with those like more open-ended, without doing it every single day. And so obviously in class, I really spent time circulating. The statistics kids maybe had some questions on the coding, but again, the way the lessons are set up, it's all there for them. They're not really asked to think, because this is just an introduction to very basic R. So they're not really asked to make super leaps and bounds. So when it came time to doing it, I will say I had one student who historically through the class griped a little bit, but that was like a year-long thing. So this was totally part of her MO. There was one day she exclaimed in class, this was a stats student, "I'm not a programmer. This is not what I want to do. This is," and then all that meant is I went up to her and sat with her for a minute and said, okay, well, let's look back in the notebook, or if a previous notebook, if we need to, where did we learn this? And can we just use that code, sample code that's there, and change it for the scenario? And she did admit at the end, she was actually really glad that she did the project, which is I don't think is any surprise. So although she had that one day where she griped very loudly, in the end, she was really, really glad to have the experience. She definitely loved the real life, the finding out about, is college worth it? When she really walked away with that message, and I think she really had fun in the end. So I did have one little resistant stats kids. For comp sci, they were, again, so into learning the programming language. There were a few times that maybe we had to meet in small groups to talk about the statistics, because the students in the comp sci class come from all different backgrounds and may have various levels of stats experience. I don't think stats experience on its own is necessary, but that just meant to do it in the 2 weeks or even in less time, I just had to spend a little bit more time answering the questions that they had about the statistics. So they kind of understood more what we were looking at statistically, but they definitely enjoyed learning R. And so, yeah, I did spend a lot of time circulating, doing very small groups work if a group of students had similar questions. I think when I do it this year, I might really figure out the times when I'll have the most students so we can do more whole group work. And definitely asking, when I was doing the small groups too, I would, once they turn their notebook in, I might call them over and say, hey, I really like this response here. And then I might ask them deeper questions about the project. Well, if you had more time, how might you do this? Where else would you like to take your knowledge of R or this project? So I really like that. And in the end, the students, I had a lot of very, very positive feedback from the students. Even this year, some of the students from last year asked if I was going to do the project again with my students. And they were pretty excited about it for them. I think, again, they liked answering that real life question. They really liked working with the big data set and learning about, we start with things they kind of already know, and then we take it so far. I don't do multiple regression in my class. And so, they really enjoyed that, and they enjoyed using the training set and the test set. That was such a new concept to them. So I know they really walked away liking that. They did like the format of the notebooks and knowing that, they could do them on their own, but also ask their friends for help. And they absolutely loved the challenge at the end. I did not think the challenge was going to go the way that it ended up going, but and the students in the classes knew each other. So I'd say, oh, what did so-and-so in stats get for their R squared value? Oh, she did? Well, then I'm going to go back and fix mine, and I'm going to tweak it a little more and try to get that better R squared value. And in fact, one student came back he came back like a week later and said, I played with that a little more. I got my R squared a little bit higher. So they were definitely, they were in it. They were in it to win it. And so it was a really, really positive experience for them. Yeah. And so with that, I'm going to hand it over to Zarek.
Awesome. Thanks so much, Jen. That was really helpful, I think, just to like hear what the experience was for your students, right? And I love that, like the sort of like that, like as Mahmoud said in the chat, like this organic peer pressure sort of emerged, and hopefully it was a friendly way.
Totally friendly.
And I think like it also, I mean, this is such a perfect example of like where students are able to see themselves in their own data analysis, right? Like this is very much about like their own college trajectory or like their own college choices. And so I think that like that the topic really like helps bring that to life.
One note on
yeah,
that
good.
is
Go ahead, Ash.
in the first notebook, and this was actually Mahmoud's innovation, they now get to look up any named college in the whole data set for its default rate on student loans. And so whatever college they are considering applying to or going to, they can see directly from the Department of Education what its student loan default rate is for its graduates, and also people who don't graduate. And I don't think data can get more personalizable than that. It's pretty cool.
Yeah, and I think this is like I feel like this is like a college counselor's dream to be able to have students like look at this data directly. And so I feel like there's several birds and maybe one stone here. Okay, so I'm gonna try to separate. We have a good chunk of time to do questions. So I'm gonna try to separate this into two buckets. First, just about like a little bit more, maybe about like the kind of like the design of the challenge and like what you all have found surprising either in prior years or like what you think like a maybe just describing like what a winning submission looks like, or like other sort of like things about the design of the challenge itself. And then I'm gonna towards the end of the webinar. We had a number of questions come in through the chat about like just like the setup, like how do I do this? What about different like logistics questions, right? Like how much time do I need? I think I saw a few questions about data privacy and like figuring out how to make sure that this is eligible for your school district. So I'm gonna do like a rapid fire like implementation round, and I'll try to cue each of you based on who I think it would route best to. But hopefully that will clear up like some of those questions, so we can like think about like different scenarios in which a school or district might be a teacher might be trying to implement this. And if we can't, I think it goes without saying, but if we can't give you the perfect information today, we'll follow up with more details about any other questions that come up for things that like I think the organizing team here maybe didn't expect. But I think we'll try to cover as much as we can. So I need to dive in on like the challenge, like content and substance. We first wanted to get a sense just like, and this is open to the group, any surprises throughout the process, especially like in the first year of doing this? When you were first implementing this, what, especially thinking about like a first time participant, or if I'm a teacher implementing this for the first time with my students, what tips would you have for someone jumping into this for the first time? And are there any like surprises from year one that you think might transfer or help as you're approaching doing this challenge for maybe your first experience?
The thing that surprised me the most was how much we could do with the limited amount of code that we really use. Because the data set is already clean and ready for analysis, the amount of code that we need to utilize to do the exploration and to do the visualizations is very limited. And R is not always talked about in terms of the first sort of language for data science, especially in the high school setting. People want to do things in Python, but the statistical modeling aspect of R and how easy that is compared to having to get another package or library in Python makes it so much more accessible. Like if you're fitting multiple linear regression models in Python as opposed to R, it's just a very different thing. So to me, that was really surprising after we kind of went through it and looking back.
That's really helpful. Yeah. So yeah, Jen.
I was going to say, as a first-time person, you get access beforehand, before the AP exam, well beforehand as a teacher. So I made sure to go through all the notebooks. And again, I didn't know R going in. And so I went through and I, kind of started at spots where I thought my kids might have questions and whatnot. So that was really, really useful the first time around. And yeah, I think that would be the biggest thing, is make sure that you go through it first, and have those deadlines for the students, because that's kind of easy. If, decide beforehand if you're doing it as a whole class, or if you're going to let them do that a little bit more individually, and have, that each notebook takes, 1 to 2 classes, in class only, no homework.
And Tara,
think,
hopefully that helped answer your
sorry.
question in the chat about like access the project early. Maybe Dash, if you just want to or Mahmoud, if you could confirm that, maybe detail just to help there.
Yeah, so you can actually get access right now. If you go to the data science landing page, fill out the registration form, then scroll down to steps 2 and 3, you can go into the web page on Canvas and start coding. I was also going to mention the thing that surprised me the most was the community that formed around this. I think we have this Flarum forum that we didn't know if it would get used, but essentially it's a place where you can put in your coding questions and other teachers using the challenge could answer them and collaborate. People were making guides. People were making like rubrics for grading. People were making their own little spin-offs of the notebooks, and everyone was getting really into it. And you could tell that everyone's students were getting really into it too. And we essentially quickly overloaded the servers we were working on because so many people were interested in this. And this year, we've had, based on teacher registrations and the amount that teachers have said, of students teachers have said might do this, we have an upper estimate now about 10,000 students currently registered to do the challenge after May 6th. It will be maybe less than that because not every class that registers will actually go through with it. But the size of this community and the supportfulness of this community is the thing that has surprised me the most. And definitely, in addition to the checking out the notebooks, doing them yourself well ahead of time, and checking out the guide videos from Mahmoud and checking out the solutions, I definitely check out that online forum as well to get help from peers.
Awesome. Yeah, I'll say what surprised me the most in year 1 is when the server almost crashed for initial signups, but you're able to triage, and we were able to have some great help from the course content team to open up more space. And I think we're going into this year, I think we'll even have more capacity. But yeah, that was super helpful. Just to kind of like anchor us and think about like especially first time users running into this challenge and helping set this up. But you also wanted to ask at a high level, and Mahmoud, maybe I'll start with you, and then if others want to chime in on this question. So the question we had from the chat was, this content seems pretty advanced or rigorous to me. Can you describe a little bit what like a winning submission looked like from last year? What were some of the more advanced work that student accomplished? And Mahmoud, do you maybe just like maybe touch on that like general question of like rigor and like content, and then maybe Dash, you could explain like what some of the what a winning submission really looked like.
So I think the most rigorous part is just introducing students to how to interpret multiple linear regression. That's about the most difficult part in terms of things that students haven't done before in terms of the content. For students who haven't taken any stats, they have to learn things about different visualizations, things around the 5-number summary. I think most students have done some sort of linear regression, either in their algebra class or some other class that they've had in mathematics. The coding aspect, the rigor with that has been sort of settled down a bit in the sense that we give examples of what syntax to use for the code, and then students can sort of mimic those examples when they code on their own. For the teachers, when they get access, they can look at the notebook walkthroughs for each notebook that sort of explains in more detail about the code, about the output, about where to find the output, gives a little bit more in-depth explanation as to what some things might mean that might not be just apparent or written inside the notebook. And really, that's about it. I think the rigor will come when the students start having to make decisions based on the information that they get from their code. because they have to make a decision. So they have to weigh the pros and the cons of the information they get to then decide what they're going to do in terms of their own submission, building their own model.
That's really helpful. And Ash, maybe do you want to take that and anything you want to either add on there or just kind of like describe further like what some of those winning submissions look like from last year?
Yeah, for sure. On the point of rigor, I think if the student has taken AP Stats or one of the AP Comp Sci courses, they can definitely do this, and they are up for it. Especially if you're having them work in pairs or in groups of 3 where they're all doing their own notebook and you help each other out when errors arise, or help each other out with interpreting the stuff that is outputted. It's just a recipe for success. And in terms of what winning submissions look like, I hesitate to show you what the actual winning submission was from last year, not to give away too many ideas. And also because it looks very complicated. But the weird thing about this is, starting from the basics of data science, by the time you get to notebook 4 and you're making a machine learning polynomial model where you have a train and test set and including a lot of variables in it, it actually doesn't feel overwhelming. It actually feels like, oh, I understand that the SAT scores have this slightly nonlinear relationship with default rates. And so I'm going to put a polynomial term there, but I can see here that the percent of students at the school that receive a Pell Grant is not very related to the default rate. And so I'm going to go ahead and exclude that from my model because it could lead to overfitting. These are the kinds of decisions that you'll find the students are making on their own without needing to get walked through it. I think that's the beauty of this challenge.
Awesome. And then I have one more question, and Jen, I was hoping maybe you could tackle this one. Others can add if you want. If thinking about what if you have a group of students, just hypothetically, and I know you had the opposite case. You had a group of students who were really engaged and like got like almost competitive with each other in the challenge, right? But thinking like if I have a group of students who maybe don't care very much about statistics or data science going in, like how does this challenge potentially engage them? And anyone can answer this, but Jen, I thought you might have like some experience that could weigh in on this question.
I think for the statistics kids, most of mine were interested because of that real life question. They love Skew the Script. I mean, let's be real, and they love that the real life meaningful context that we get from those activities. So to them, this was like a bigger version of that, and going deeper into it. And I think that, you know, I did have that one student who was resistant that day. But for the comp sci, again, because it was about the college, you know, the value, I think that was kind of a buy-in for them too. So, you know, maybe the explanations they needed a little assistance on. So maybe that was something I called them over to. But yeah, I didn't, you know, I might call them over and say, let's talk about this explanation a little more. But I didn't run into those kinds of issues where they were just, no, I think they were also excited for the change of pace after studying for the AP exam and having all the AP exam stuff going on.
Also super reasonable. That change of pace, I think, matters. Awesome. Okay. So I'm going to switch gears a little bit because I've seen a lot of other questions about, I'm kind of like roll through, but just like implementation, right? Like getting your head around like what this looks like. So we're going to do rapid fire, challenge setup, and logistics, and implementation questions. So first, do we have to and this is a little bit of recap from the chat, but just want to help make sure that we get these answered for everyone. Question on, do we have to pre-register our students or can we just log in and go? And then a related question that came up also in the chat is, can students register individually? They aren't part of an AP class, but are interested. So Dash, maybe you could help us there.
Yeah, so the challenge with students can only be used May 6th and beyond, timing it with the end of AP testing. And that's just mainly for server reasons. We want to make sure that no full cohorts of students are using all this stuff before we have full server capacity ready. And so, but you're welcome as a teacher to explore the stuff beforehand. So you don't have to pre-register the student individual accounts necessarily before May 6th. You can just make your own and start exploring. And then May 6th and after, you can get the students registered and get going. And then in terms of like individual students who are not necessarily a part of the AP class, but are interested in doing this, I think as long as they are a high school student at your school and they have the support they might need from peers or from you to get this done, I think that's okay to do. I would just in your registration, make sure to include those students in your student count.
Awesome. Great. That's super helpful. Okay, we had a couple of questions also come in on data privacy and like your district IT or just data privacy rules. And we had one person in the chat say, I need to get this approved before my students could register. So you're able to help me with that approval process. So Dash, that might be a question for you. And then Jen, there's a question from someone in New York where they have pretty strict, or quoting from the chat, says that they have strict data privacy laws in New York State. So wondering how you handled that and if there are any like tips or tricks for doing the implementation there. So Dash, if you want to chime in first.
Yeah, so on the specific data privacy point, we handle data privacy very seriously with this challenge, and ultimately we try and make it so that we're only collecting the most information that we need in order for students to actually complete the challenge. And the only students we're collecting any more information from are those who are submitting to the competition piece, because we want to be able to reach out to them and confirm their work and then feature them publicly for their great work. So students who opt into that are going to be kind of opting into potentially sharing more information if they are a finalist. But for most others, we try to make it such that we're compliant with even the most stringent privacy policies. But I know that some districts will want to take a look themselves. So in the chat here is our specific privacy policy that you can share with your district officials to have them vet it. And if there's any questions that arise, please do reach out.
And Jen, any extra info to add maybe from just your context in New York or any experience?
Yeah, no, we do have the strict rules. I passed it on to our IT department, and I'm sure if I know they have a form that needs to be filled out, like saying, hey, we really mean it. We're not going to sign, we're not going to sell the student information. So that it was that simple. I just said, hey, I want to do this project. Here's the privacy information, and it got on the approved list.
Awesome. Thanks for helping us navigate that. And is there a central contact info that someone should reach out to if they have questions about this or other kind of like logistics and implementation questions?
Definitely, reach out to contact@skewthescript.org. I'll put that in the chat as well.
Awesome. Yeah, I know navigating that kind of case by case can sometimes be tricky, so I want to make sure that that's easy for folks to reach out to. Okay, had another question, and Mahmoud, I might start with you on this and then pass it around to the rest of the group if you want to add. We had a question in the chat that I'm planning on using this challenge with my CS principal students. Most of them are 10th graders who have not taken AP statistics, but have either had or are taking Algebra 2. Do you think this would be doable for them? Would it work for any either 10th graders or even maybe younger?
I think it would, because in the notebooks, there are additional resources for links to Skew the Script content or other content that can explain some of these statistical concepts that the students may not be familiar with. Things like the 5-number summary, what is a quartile, some things around simple linear regression that may be a little more in depth than what they've already experienced, but will likely experience when they go on to other higher levels of mathematics. So I think it's not about, as Dash has pointed out, so much the grade or the content. It's more about, it's just an experience that many students I don't think will have ever had. And Conrad Wolfram said this thing that was very interesting to me. Like, we live in a time now where the machinery that is used in the real world to solve real problems, we can use that same machinery inside a classroom. So real data scientists are sitting in places now doing things with data on computers. And we can have a very similar experience in a classroom with students. And to me, that's extremely exciting, because we're not trying to make everyone a data scientist, but everyone should have some familiarity with working with data and becoming data literate, because this is just one decision in your life. Choosing a college. You're going to have to choose a 401k or not. choose stocks or not, choose healthcare providers or not. And so you want to have some ability to verify for yourself what you're doing is right for you.
That's really helpful. Any other thoughts there from the group? If not, we'll keep our lightning round running. Hopefully that helped address that question. Let's see. Another question: can the challenge be done in groups or individually? And maybe just a general question of like how to split up and think about like your classroom management. So we had one scenario of an educator who's teaching this to 3 different classes, wondering within each of those classes, can I divide my students into smaller teams? Another question was like, hey, most of my AP students are seniors. A lot of them are graduating. I only have like a small number of juniors who are going to still be around at the end of the year. So just wondering like recommended size, arrangement of students, etc. Maybe Dash or Jen, if you have any recommendations there.
Yeah, I'll just give a logistical note, which is if every student gets their own notebook, that's often a good thing, rather than having multiple students try and use the same notebook, because then they have to share logins and that gets messy. So every student gets a login, gets their own notebook, but then having them work in groups such that they can collaborate and run errors by each other, run code by each other, with like groups of 2 to 3, I think is the best practice.
That's naturally how it happened I have 2 classes that I taught it in last year. This year it'll be 4. And in that case, yeah, the notebooks are individual. So each student had to turn in a PDF of their work, but they certainly were welcome to work together and say, hey, I'm struggling with this one. How did you handle that? Or, what about this question? So they definitely collaborated in terms of like that little extra assistance here and there, but their notebooks were their own.
And then a very related question that Neil asked in the chat is that can students share a Jupyter notebook in the same way like a Replit can be shared, or in the same way that like a Google Doc link can be shared, etc.?
We at this time in the challenge platform that we have, just due to kind of the server constraints and data privacy constraints, they won't be able to just share a link to their notebook and then have anyone open that. But what they can do is download their work as a PDF that's pretty well formatted. And actually, we've improved the formatting since last year to make the questions more identifiable, and then share that with you as an easily readable PDF.
Great. Okay, that's helpful. Awesome. Neil, that was good timing. It's suited well to my conversation. Okay. Let's see, next one. And this may be a little bit related to that topic. Are we able to monitor our students' progress through the notebooks as they're working on them? Or is that not currently possible? Dash, that's probably a question for you, or Mahmoud, I don't know.
Actually, I would love to hear Jen's thoughts on this, and like what it was like to monitor as kids were working.
I monitored by walking around and seeing where they were, because I don't have access from my end. I can't see what they're live. I can't see what they're doing from my computer, but walking around, I was able to see where they are. And again, I had those soft deadlines, so I was expecting their PDFs by a certain date. So when they finished a notebook, they would save it as a PDF and then put, they would turn it in on Google Classroom, and then I was able to look at them. And not only for completion though, so sometimes what I was doing is I would read through them and make myself notes. Like when I see this student tomorrow, I want to talk about this with them. So again, so I could walk around in class and just see a little bit of what they were understanding, but also where they were in the notebooks. But it was really important for that feedback from me as well, to go back and give them feedback on the answers they had put in the notebooks they did turn in.
And Jeb, we also had a related question on just like how you went about like grading, generally speaking, like how you thought about like that on the back end as you were evaluating students' work.
During the data science challenge, it was just on completion, because to me, this was a learning experience and I wasn't expecting them, I wasn't testing them on this. So this really was a learning experience for them. And I say that, but then after the data science challenge, we have a project that we do. So I used to do a bigger project, but a scaled down project, but now they have even more tools in their toolbox. And I think that I'm actually really excited for this year since, I had last year under my belt. I'm really excited about this year's projects. And now like, okay, I'm way more comfortable with R than I was last year. And how can I help you do this really meaningful project that I then can grade you on, right? Like, and so it'll be different for the different classes. Obviously the statistics class, it will be a statistics-based project, really heavy. Whereas in the computer science class, I have some ideas floating around for that one, but it'll still be, it's all project-based after the AP exam and after the data science challenge.
Awesome.
And I think as a general recommendation, if it's your first year using the challenge, I would stay away from tying any big summative grades to the work. And I think since it's after the AP exam, since sometimes things can go wrong, like the school Wi-Fi is out one day, it's not something that I think I would put a high stakes grade to. But as formative grades or as completion grades, I think that's totally appropriate.
And then maybe one last question just on like thinking about how like structure this within the time that you have. How long would you all recommend for the challenge? Like how many classroom days or how many periods? Say if you have a varying schedule of students after the exam.
I did mine in a little over a week. I think I did mine in last year 6 to 8, but it really depends on when I have all the students together. So basically, yeah, 6 to 8, I would say. I know you could use as many as 10 easily, but for me, I think it's somewhere in there.
Yeah, I think if you have like 50-minute class periods, given the survey results we got from teachers, most would complete it in about 6 50-minute class periods, 6 to 7 roughly. And I think if you have some students who want to go extra deep into, say, making their own models for a prediction competition, they might need a little bit more time. But that's typically what we saw it ran for.
Awesome. Great. Okay. I have one. So we're coming up in the hour. I have one last question. Maybe less about the implementation of the challenge itself, but I'm wondering, I know we had a few students who popped into the webinar, and I'm wondering either for students directly or for teachers to pass along to their students, what advice would you give them as they're navigating this? Any tips or tricks that you think would help them succeed in the work?
Just take their time and have fun. It's supposed to be fun, right? And it's answering this really meaningful question. So they have all the tools are in the notebooks. Everything they need is in the notebooks to be successful with this.
The thing that I would suggest is going to sound very different than what one would think, but there's sort of a story that goes along with each notebook. And try to immerse yourself in the story of trying to make a decision on which college to attend. And at each endpoint of a notebook, there's sort of a cliffhanger that using the things that you were doing in that notebook, you have a partial answer, but it's not a complete answer. And so you have to go further and you have to go further. And so when you leave the challenge and you continue your studies, whether it's additional years in high school or you go to college or community college or you join the workforce, use that same structure. When you get to the end and you haven't really resolved it, the way life works is you have to learn more. So go learn more and let understanding and helping yourself to make good decisions be the motivation for the things that you learn. And you'll find that if you do that, you'll learn through your whole life.
Advice both for the challenge and for beyond. Yeah, you want to close this out?
I was to say I couldn't say it any better myself, so I'll let Mahmoud have the final word there. That was amazing.
Awesome. Thank you all so much for our discussion today, for sharing your thoughts and your experiences with this challenge. You all can register for the challenge now using the link. If you research it, if you can drop that in the chat once more. Anytime before April 19th, that's the deadline for signing up for engaging your students in this work come this spring. We are so grateful for having you all join us today. Just wanted to say, make sure you're following us at Data Science for Everyone and our community channels to learn more about this challenge or more about the events like this one and our friends and partners at Skew the Script, Coursera, and North Carolina State University, who helped us do the research to evaluate this program. Wanted to just quickly share also our resource center. We have a huge clearinghouse of any K-12 classroom materials, resources, software, et cetera, that have been created for implementing these experiences for your students. And finally, if you requested a certificate of completion for the joining today, will be emailed to you, and you can get in touch with Marisa about those details and make sure that your time was valued. Thank you all so much. If you have additional questions as relates to the implementation of this challenge or for how to bring this to your students, I think Dash shared that contact info if you get in touch with any other questions as you're trying to implement this. And we'll do our best to get some answers to you quickly. The speakers are okay. We can also hang out around just for like a few minutes if there's any other just like wrap up questions that folks want to drop in the chat to make sure we cover everything today. But with that, we'll get you out of here just 30 seconds over. Thank you all so much for joining. Hope you have lovely evenings, and best of luck to your students for engaging in this challenge. We're really excited to have them in year 2 of the Data Science Challenge.
Bye. Thank you for inviting me.
Thanks so much. Let's see, I'm trying to see if we missed any questions. I try to capture the best as I could. Did the notebooks build on each other? Dash, I saw that come through. And maybe just to clarify that.
Yeah, they do.
Yep, great. So you likely best to use them in order.
Yeah, I would say you have to use them in order. As Mahmoud said, there's like a story. And in addition to the story, there are prerequisite skills you get in the early notebooks for later ones too.
Great.
And here's a question that says, will there be a lottery to determine who can use the challenge, or does everyone able to do it who registers?
So the goal is that everyone gets to do it. And also, if needed, there will be a lottery system if there's just too much interest and too many students to fit the server space that we can muster. We hope it doesn't get to a point where we can't accommodate everyone. But the best thing to do is to fill out that registration form by April 19th. And that way you're guaranteed at least a lottery spot. If we do end up having to do a lottery for enrolling your students in the challenge, and of course you can complete the notebooks yourself, walk through it, evaluate if you want to use this with your students prior to the lottery happening. But our hope is not to have to do that and to allow everyone, but there is that possibility if we go viral. Yeah, but we're working really hard in the back end. Specifically, Coursera, our partners, are working really hard in the back end to make it work.
Thanks all. Thanks so much for your great questions.
All right.
Thanks,
Good to see you,
Jeremy.
Jeremy.
All right. Take it easy.
Thanks, guys.
All right.
And Mahmoud, Dash, and Jen, thank you so much for joining and for leading that discussion. Thought that was fantastic. And I'm so excited for year 2. This is going to be so cool.
All right. Take it easy, everyone. Have a good evening.
Have a good evening.
Bye.
Bye. Thank you.